Hello everyone, I am Suman Sadhukan, a data science enthusiast from West Bengal. Here in this video, today I will be discussing about the Capstone project uh, from Module 5, Mathematics and Applied Statistics from Alma Mater. In this project, I will be discussing about or explaining about uh, 5 interview questions. The project is all about uh, write the solution to any 50 interview questions out of 80 total questions. So in this project, I have uh, created solution for the 50 interview questions out of the 80 questions of my choice. And among these 50 questions, I have discussed 5 questions in this video as per the project requirement. So my first question is, what is vector in mathematics? So a vector in mathematics is a quantity that has both magnitude and direction. The vector are used to represent physical quantities like force, velocity, and displacement. They are typically directed as arrows, where the length of the arrows represent as magnitude and the direction of the arrows indicates the direction of the vector. So vector can be described in different ways depending on the context. Algebraically, as an ordered set of numbers that define the component of vector along each axis in a coordinate system. For example, v equal to v1, comma v2, and v in 2D space, and v equal to v1, v2, v3 in the 3D space. So for the coordinate system, we can represent vector in this way. This is the point in coordinate. This is two-dimensional coordinate, and this is for the three-dimensional coordinate. And graphically, as directed the line segment in a coordinate plane or space. Key characteristics: magnitudes, the length or size of a vector. So uh, see this picture. This is a Cartesian coordinate system, and this is the x-axis and this is the y-axis, and our vector is 4 comma 2 or 4 I cap comma 2 plus 2 j cap. We can represent the vector in this way also. So you can say that the v is a vector in the 3D coordinate system because there is 3 component. This one is along the x-axis, that's 2 is the y-axis and 3 is the z-axis. We can denote it is uh, uh, denoted it like in this way, or we can denote it in this way, the column matrix form. Okay, or basically we have seen that in the mathematics in our school days or physics books, we can also represent it this way. I cap is the unit vector in here. I cap is unit vector in the x-axis. J cap is unit vector in y-axis, and k cap is for the z-axis. So this is notation wise vector. This is vector, and as you can see, the vector is a point in a coordinate system, and it is originated from. We always assume vector is originated from origin, which is 0 comma 0 or in 2D, and for more dimension 0 comma 0 comma 0 as origin for higher dimension hyperplane. So this is the direction. This is the starting point, and this is the ending point. This is start from here and ends here. So this is the direction, and the length of the vector is uh, as I have mentioned, it is the magnitude. Okay, it is called as a magnitude. So how I can evaluate the magnitude? So for an example, here you see 3 comma 4 is a vector in 2D space, 2D, and is represented as 3i plus 4j. Then the magnitude of the A vector is denoted by this symbol, is nothing but here in the graph we can a picture we can see that this is a triangle. This vector forms a triangle. If I join this, okay, just think it in this manner. Then this form 90 degree. This is a perpendicular. Then this become the hypotenuse, and from the triangle, the property of triangle, we apply Pythagorean theorem here. So the Pythagorean theory, as mentioned, the hypotenuse square is equal to the sum of squares of other side. Okay, so this is the base and this is the altitude. So we can derive this magnitude as in this way. This part is 3 unit, and this part is 4 unit. So 3 square plus 4 square, which is equal to 25 and equal to 5. So the magnitude is 5. The magnitude of the vector is 5. In this way, we have derived the magnitude of a vector, and the base is the Pythagorean theorem. Uh, so I have mentioned everything, the notation and the type of vectors. There is 10 commonly type of vectors. Zero vector, the vector is said the zero vector when the magnitude is 0. Means the starting point and end point is same. Unit vector, the vector is said to be unit vector when the magnitude of the vector is 1 unit in length. And the position vector, let's suppose point x taken in a plane is said to be position vector. It simply denotes the position. Let Ox be a point in a plane concerning its origin. Let us consider O is taken as reference origin and X is arbitrary point in the plane. Then the vector is called the position vector of a point. Co-initial vector. The vector is said to be a co-initial vector when two or more vectors have the same starting point. Like or unlike vector, the vector having the same direction are like vector, whereas a vector having the opposite direction are said to be unlike vector. Coplanar vector, three or more vectors lying in the same plane are known coplanar vector. Collinear vector, vectors that lie in parallel line or same line concerning their magnitude and the direction are known to be collinear vector. Also, it also known as parallel vectors. Equal vector, the two vectors are said to be equal when they have the both direction and magnitude equal. The even if they have different initial point. Displacement vector, the vector AB represents a displacement vector if the point is displaced from A to B. And negative of a vector, any vector with the same direction but the opposite direction is given. Any vector with the same magnitude but the opposite direction is given, then this vector is said to be a negative of a vector. Move ahead to the second question. What is the concept of derivative in calculus? So derivative, as we know, that derivative is also called as the differentiation. And the most important things in one of the most important part of calculus is derivative, and the base of derivative is limit. So to know the derivative from the scratch, everything about derivative, then we have to first study about limit and continuity concept, because uh, to derive a derivative of a function at a certain point, we first ensure the function is differentiable at that point. For that, we have this is must to having the concept of limit and limit and continuity. Then, so what is derivative? Derivative is are defined as varying rate of change of a function with respect to a independent variable. The derivative is primarily used when there is some varying quantity and the rate of change is not constant. The derivative is used to measure the sensitivity of variable one variable, and that is the dependent variable, with respect to another variable which is the independent variable. So the mathematical expression or the definition is, let x be let fx be a real valued function. The derivative of fx with respect to x is the function f dash x, and is defined as df by dx equal to f dash x equal to limit h tends to 0 f of x plus minus f of x divided by whole divided by h. So this is the uh, expression of how we uh, derive the differentiation of a function. Okay, so geometrically, think the see this picture. This this blue line, this is our function fx. Consider is the function fx, and the curve of fx is the blue line. Then this is a point, the x value is x and corresponding y value is fx. Then and take a function, if take a point at x h plus h, the value of the function fx is f of x plus h, and this is the point. Then uh, this the increment of x is denoted by h here. And if I want to uh, if I want to uh, derive the differentiation of fx at x equal to x, then this is the line, this is the tangent, and the slope of the tangent is nothing but the derivative of the function fx at x equal to x. Okay, so I have mentioned it. So the slope is often experienced the rise over the run, the Cartesian term. The concept of derivative with the straight line. The straight line equation is y equal to mx plus c, and the equation of the straight line in the slope-intercept form is this, and where m is the slope of the line, and c is the intercept of the line. So here this is the line in the two-dimensional plane coordinate. So suppose this is our function which is y equal to 3x minus 2. So this is the straight line. So there's a straight line intercept the y-axis at minus 2, and I want to derive the derivative of the function. Then what I do, derivative is nothing but change in y per unit change in x by per unit change in x. So here the change is from 1 to 4 the change is 3, and from 1 to 2 the change is 1. So this is 4 minus 1 by 1, this is 3. And as this is a straight line, the derivative at any point of the function is constant. The derivative is not varying for this function, like straight line function, the derivative is constant. But for a function like curve, this function, like this is a function of x into sine of x square plus 1. So if I measure the derivative here, the derivative and the measure the derivative here, or every point the derivative is different. Derivative of function is different. For any different value of x, the derivative of the function is different, and these represent how the function is changing for a slight change in x, for the slight change in other variable. So this is derivative is nothing but the instantaneous change of a function. Then the question number 3 is, how do you detect and treat the outlier in the dataset? So outlier are the values at extreme ends of a dataset that stand out greatly from the overall pattern of the value in the dataset or graph. Generally, the number of outliers is very less in compared to the other data points, but the impact is not negligible. A model often fails to capture important characteristic of a data for having outlier in dataset. The outlier can pose a significant threat to the model performance, particularly in algorithms sensitive to their influence, such as linear regression and k-nearest neighbors. So there are two type of outliers. Like true outliers should always be retained in our data set because these just represent natural variation in your sample. In our data set, the natural uh, outliers are true outliers, but the outliers are that are not natural, that is present because of few reasons like measurement error, data entry or processing error, and representative sampling. These are called out other outliers. So this type of outliers is problematic because it's inaccurate and can distort our research result. So there are certain ways to calculate outliers using visualization. We can use software to visualize our data with like a box and whisker plot. So you can see the data distribution at a glance. This type of chart highlights the minimum and maximum values, the range, median and interquartile range in your data. So many computer programs highlight an outlier chart with an asterisk, and these will lie outside the bound of the graphs. Then the second method is statistical outlier detection with z-score. The criteria: any data point whose z-score fall out of third uh, standard deviation, it considered as an outlier. Like how we can measure the z-score for a data or for a feature. So z-score is basically nothing but x minus the individual points of a data minus the mean of the data divided by the standard deviation. So in this way we measure the z-score, and any value is uh, greater than the positive z-score or the negative z-score is uh, So if a value has a high enough or low enough z-score, it can consider as outlier. So as a rule of thumb, values with z-score greater than 3 and less than -3 often determined to be outliers. So the value can z-score between -3 to 3, then this will not consider as an outlier, but extreme points like below -z and above plus z, below -3 and z equal to above +3 is considered as a outlier. And for using interquartile range, so interquartile range tells us the range of the middle half of our data set. You can use it the IQR create fence around your data and then define the outliers as any values that falls outside the fence. So this is the structure of box plot. So in the box plot, what happens? This is the lower fence, this is the outer fence, and this section is called as the interquartile range or IQR. The first quartile, Q1 is 25 percentile, this is 50th percentile, this is called as median, and Q3 is 75 quantiles. This is the IQR range, and this is the minimum value and maximum value, like upper fence and lower fence. So any point greater than the upper fence is called as treated as outliers, and any point is lower than the lower fence is called as the outliers, also called as outliers. Interquartile range, how we can measure this interquartile range is nothing but first of all I have to sort the data from low to ascending order, low to high, then identify the first quartile. We have to measure what is the 25 percentile, 50th percentile and 75th percentile. Then we calculate the IQR with this formula, Q3 minus Q1, and calculate the upper fence with this formula and lower fence with this formula. Then any point above upper fence and any point below lower fence is called as outlier. So dealing with outlier. So after identifying the outlier, I have to decide what to do with them. The main options are retaining or removing them from the data set. This is similar to the choice you faced with when dealing with the missing data or null value. So what does it mean? After detecting the outlier, we have to decide what should I do with the outliers. Should I remain it in the data set or remove it? So if I want to retain outliers, so uh, the just like missing values, the most comprehensive option is to keep the outlier in the data set. Keeping outliers is a better option when you are not sure if they are errors. With a large sample, the outliers are expected and more likely to occur, but each outlier has less effect on your result. Your sample is large enough, the central tendency and variability of your data won't be affected by the couple extreme values. When you have a large number of values, and if you have small dataset, you may also want to retain as much as possible to make sure you have the enough statistical power. If your dataset ends up containing many outliers, you may need to use the statistical test or more robust to them. And the second option is just remove the outlier, but this is kind of tricky things. We have to very conscious whether should I go for retain outliers or remove outliers. Then probability. The what is probability? This is question number 4. Probability theory is a branch of mathematics and that investigate the probabilities associated with a random phenomenon, and the random phenomenon can have several outcomes. Probability theory describes a chance of outcome of a particular outcome by using certain formal concept. Probability theory makes use of random variables and probability distribution to access the uncertain situation mathematically. In probability theory, the concept of probability is used to assign a number and assign a numerical description to the likelihood of occurrence of an event. Probability can be defined as the number of favorable outcome divided by the number of possible outcome of an event. So below are the example of probability, like we can toss a coin and there is two result after tossing a coin, whether it can be a head, whether it can be a tail. Then this then among the two results, what is the probability of tail? What is the probability of head? So in this these are the example of probability, and we can also roll a dice, roll a fair dice. So what is the probability of the number is getting more than 3? This is kind of a probability thing. Probability formula is nothing but P of A equal to number of favorable outcome to A. A is nothing but an event, like as I have mentioned. Event is like the probability of getting an head, probability of getting a number which is more than 2. These are called an individual events, and the total number of possible outcome. The total number of possible outcome. So here I have an example. P of A is the probability of the event occurring. For example, let's consider a random experiment for rolling a fair dice. And the random event is defined as the getting an even number associated with the with this random experiment. Then the sample space is equal to, sample space is nothing but the number of the total all possible outcomes. So 1, 2, 3, 4, 5, 6. This can be the possible all possible outcomes of after rolling a fair dice, and the event is 246 because I have defined the event as getting an even number. These are 246. So the probability of P of A equal to number of elements in A, which is 3, and divided by number of elements in A, so this is 6. So half, this is 0.05 or 50% probability. So there are some components in probability theory like random experiment, sample space, event. The random experiment is nothing but a trial that repeated multiple times in order to get a well-defined set of possible outcome. Like tossing a coin is an example of random experiment, or rolling a dice is a uh, example of random experiment, or tossing two coin at same time is also a random experiment. Sample space is nothing but a set of all possible outcome that result from the conducting random experiment. For example, the sample space of tossing a fair coin is head and tail. Event is nothing but an event is a set of outcome of an experiment that form a subset of a sample space. Type of events are given as independent events, dependent event. What is independent event? Independent events is not affected by other events. Are independent events. Dependent events are events that are affected by other events, known as dependent event. Mutually exclusive events, events that cannot take place at the same time, are mutually exclusive events, and two or more events that have the same chance of occurring are known as the equally likely events. So conclusion, probability theory, a branch of mathematics concerned with the analysis of random phenomena. The outcome of a random phenomena cannot be determined because it occurs, but it may be any of the several possible outcomes. The actual outcome is considered to be determined by chance. Then move forward to our next fifth question, which is our last question for discussion. What are some common measures of central tendency and how are they calculated? The measure of central tendency is a part of statistics. Uh, measure of central tendency are the values that describe a data set by identifying the central position of the data. It is defined as statistical method that can be used to represent the entire distribution of a data set using a single value called as a measure of central tendency. Any of the measure of central tendency provides an accurate description of the entire data in the distribution. There are generally three measures of the central tendency commonly used in statistics, that is mean, median, and mode. Mean is the most common measure of central tendency used to describe a data set. These are the three kind of measure of central tendency. So X, for example, in the data set we have we have 1 2 3 4 5 6 6 point. Okay, so mean is nothing but the average. So what how we can come up with the mean? So first of all, summing all of the data point, then dividing it by the number of data points. So this is summing up, it can be, it is 28 after summing up, and 6 point, that is divided by 6. And mode is nothing but the most common value, the most frequent value in a set. So 7 is like repeating two times, and the other point is repeating only once, that is 7 is the mode uh, in the data. And median is nothing but the middle value of a value of a uh, data data set. So 1 2 3 4 5 6, 6 number are there, that's why the middle value, this is even, the number of points is even, that's why the middle value is calculated by the uh, the two number of the middle and summing it up and divided by 2. But if the number of uh, uh, elements in the data set is odd, then the middle value will become the median directly. So these all are the things, like how we can measure the mean, as we have discussed earlier in this in short form. A sum of the terms and number of the terms, that is represented by the mean is represented by the sample mean is represented by the x bar is equal to summation of fx divided by summation of f. And median is nothing but for for odd number of observation, median is nothing but the n plus 1 by 2th item, 2th term, and for even n plus n by 2th term plus n by 2 plus 1th term divided by 2. This is how I can uh, derive the mean or measure the mean. Median, sorry, this is median. And mode is nothing but the central tendency measure of center one of the measure of central tendency, and it is the most frequent value in a data. Then this is the formula with which we can derive the mode. And one more thing I want to discuss. The major advantage of using median is as a central tendency is that it is less affected by outliers and skewed data. We can calculate the median for different type of data, group data and ungrouped data, using the median formula. So for mean, if we have data that is having outliers, or the number of outliers is very high, or the distribution of the data is skewed, whether it is positively skewed or negatively skewed, that is mean this is, the data set distribution is not normal, then the mean will affected by the outliers, and the influenced by the outlier, and this does not give a proper central tendency, proper middle value of a data. That's why in this case median comes into the picture. For median, the how we the method with which we measure the median is uh, created in some way that it will be less affected, or it will not affected by the outliers of the data. That's why a median is more effective or more useful in that case where there is a lot of outlier present. So this end our conclude our discussion, presentation. Thanks for having me.